Hey guys, Cal here, classfordespairs.com, and today we are back again with another technical video. In this video, I'm going to show you how I line bore a crankshaft bushing. This bushing is going to be fitted to a 1966 Triumph 500 motor. This is a unit construction. So the bushing that I'll be using today is a 30 under bushing. This is a solid bronze bushing made by Kibblewhite Precision Machining. Now, before I install this new crankshaft bushing into the crankcase, there's a couple modifications that I would like to do to the bushing to help with oil flow. The first thing that I'm going to do is grab my magic marker and I'm going to put a little bit of color on all four of the cross drill holes. And essentially what I'm going to do is use this carbide burr, and I'm going to add some channels on top of the four holes, both on the inside and the outside of the bushing. And this is going to allow oil to work its way into the bushing and then into the crankshaft. But the channels itself is going to make it a lot easier for the oil to flow in place. So if you have just a bored hole and it's straight, it's a little bit more challenging for oil to kind of turn at a 90-degree angle and work its way down. But if we add a nice bevel or channel, whichever you would like to call it, that will help oil work its way inside. So once we've done that modification, we're just going to get some carburetor cleaner and we're just going to clean the bushing and we're going to inspect it. Now that everything is nice and clean, all four holes look good, so we're ready to move on to the next step. We're going to use our micrometer to measure the outside diameter of the bushing, and the reason why we're going to do this is because the outside diameter of the bushing will tell us what the interference fit is. So we're going to measure it in two different spots on both sides of the groove, and then we're going to write down the tolerance on the outside or the flange of the crankshaft bushing. Now that we have the outside diameter of the bushing recorded, we're again going to set up the micrometer to that dimension. Then we're going to get our Starrett bore gauge and we're going to zero the bore gauge out using the micrometer. So essentially the micrometer will be the master, and this is going to tell us the interference or press fit inside the crankcase. So this is a very important step. So based on the OD of the bushing, we have about 1.5 to 2 thousandths press fit. Right here we have a special plate that I made. This is a steel plate and I went ahead and surface ground it. So the flatness from one point to the other on all sides is within 1/2 thousandth, so it's very accurate. And I'm going to basically bolt this plate to the timing side or gasket surface, and in turn I will actually use this plate to bolt to the mill, and this is supposed to remove distortion when I'm indicating off the crankcase half. So I'm also going to use it to be able to press in the crankshaft bushing. So it's definitely a handy tool to have, and it definitely helps out when you're trying to bore the crankshaft bushing. It's really accurate, it's really strong, it's really rigid, and that's exactly what you need when you're boring the bushing. Now that we have the plate bolted to the timing side, we're going to use some Sun & Press Fit lubricating oil. We're going to lubricate the outside of the bushing and also the inside of the housing. It is very important to always lubricate anything that you're pressing in together, whether it's bushing, sleeves, valve guides, etc. If you don't have any press fit oil, you could also use anti-seize, I believe. You can use motor oil, grease. Anything is better than going in dry. So that's my recipe for good success when it comes down to pressing things in place. Now that the timing side is done, we're going to move on to the drive side. Again, we're going to put some Sun & Press Fit oil inside the housing and also on the OD of the inner bearing race. And the reason why we're going to install the bearing race is because we're going to indicate off the drive side. So a little bit later on in the video, that might make more sense to you, but it's going to be the same process. Heat the entire case, and with the inner race being a steel material, it should drop in place pretty easy. We're using the ram or the arbor as simply as a guide to make sure that it goes in square. Alright, so with some additional heat, we can see that the inner race has dropped into the case, so everything is looking good. Now we can proceed to the next step and start to get this bushing boring on the way. The most important step, as far as I'm concerned, is making sure that the mill spindle is perpendicular to the table. So I'm using a tool by Edge Technology to help me find if that is true. And based off what I see, the table is at 0 all the way around, so we are good to go, and we can feel confident that we're going to bore a straight hole, not a skewed hole. Now that we have the crankcase on the table, we're going to spend some time setting up the crankcase. Very time consuming. Obviously, we have to get everything in place to be able to bolt it down. We need a positive area for it to bolt down that doesn't cause any type of distortion. Right here I'm doing a curious check running the indicator up and down the bushing just to see if it's skewed. I'll be using this Blanchard ground plate that will sit on top of the crankcase halves, and I will spin the indicator around to make sure it's 0 all the way. So that way the crankcase half is parallel to the table. Now that the timing side crankcase half is parallel to the table within a few thou, which I decided was good, we're going to get the drive side case bolted to the timing side, and we're going to use all of our studs and screws. We're going to tighten it just like final assembly so everything distorts together. Here we are doing another curious check. I'm just checking to see if the drive side primary gasket surface is parallel to one side or the other, and it's within a few thou. In my honest opinion, considering how high the cases are, all the distortion, I think that's pretty good. Now that the drive side is bolted to the timing side, we need to find the center line of the timing side crankshaft bushing. And to be able to do this, we're going to use our indicator to pick up the center of the bearing race. So this is the inside bearing race that we pressed into the drive side as shown in the video a little bit earlier. Since bearings are a precision piece, I know and feel confident that the inside race is going to be round and true. So that's pretty much the logic behind using the inner race to find or pick up the center. The tools that I have are very simple. I'll be using a Micro 100 solid carbide boring bar that I lapped off camera, and then I'll be using my APT boring head. First things first, I'm going to be using my Starrett telescopic gauge, and I'm going to measure the inside diameter of the bushing. Now, I do understand that the bushing is 30 thousandths under from standard, and I do have that catalog dimension, but with distortion, with the bushing being pressed in the case, we need to find the actual true inside diameter so we can kind of get an idea of how much material that we need to remove from the bushing. Now that we have the bushing inside diameter recorded, we are going to insert our APT boring head into the spindle. And always, first things first, make sure you wear your safety glasses to protect your eyes. Before I do any machine work, I need to make sure that the depth is set, and we don't want the tool to collide with the bottom of the plate. So I'm setting the depth using the adjustable screws on the quill. All right, so we're ready to go. I have the mill set up at 175 RPM, and we're essentially taking it easy. We don't have to do any fast feed rates. This bronze material is pretty hard, so surface finish is an absolute must. We must be able to retain a really nice surface finish because it is a bearing surface area. So we're doing about 5 thousandths feed rate per revolution, and as we start to do our first passes, we can kind of get an idea of where the hole is cutting, which sides it's cutting, because there is some bushing distortion. And then we can also check and hear if there's any chatter based off, again, what we can hear and based off the finish that we're getting. All right, so we're looking good to go. The Micro 100 boring bar left a really nice finish. So that means we selected the right tool, RPM, and feed rate. So everything's good to go as far as that, but we still have more work to do. So right now we're going to use our micrometer, and we're setting it up to 1.4203. That is going to be the dimension of the crankshaft based off the dimension that I got from the bushing after I bored it. So I'm setting up my Mitutoyo bore gauge, and we're going to zero out this dimension, and then we're going to go to the the timing side crankshaft bushing, and then we're going to measure the inside diameter to see what type of clearance that we have. So with the micrometer set up at 1.4203, that will give us a 1.5 thou approximate of running clearance, which is ideal. That's what I was shooting for. So AJ over at Richter Machining, I will tell him to grind the crank to 1.4203, and yes, he can actually hold that tolerance. So that way we can get that 1.5 thou clearance that we need. Just doing some more checking, making sure that it's a 1.5 thou from the top to the bottom, basically 360 degrees. And from what I see, it's a couple tenths off, so I think we're good to go. Now, some might call me paranoid, but I look at it as saving time, especially down the road. Before I get the crankshaft back or have AJ grind it, I simply get some round stock, which is about 1.5 inch OD, and I'm going to essentially make a shaft that would replace the crankshaft. So this is my checking method to make sure everything is in alignment. One side is going to be pressed in the roller bearing, the inside roller bearing, and then the other side will be the exact same diameter as a crankshaft, which is 1.4203. So if I put this piece in the crankshaft crankshaft and bolt everything down and it rotates, then I know I have perfect alignment. So it's simply just a checking piece before I get the crankshaft. If for some reason there's a misalignment, I will know based off this piece here. All right, so we have the moment of truth. We're going to grab the piece that I made. We're going to put it inside the inner bearing race. It spins nice and smooth. We're going to add some assembly lube on the journal that's going to be going into the crankshaft bushing. So we just want to make sure that's nice and clean and lubricate it. Then we're going to get the timing side crankcase and we're going to offer it to the drive side, followed by a couple taps just to make sure everything fits. So the fact that it does fit, so far so good. And then we will move forward as far as bolting all the pieces to make sure that the case is tight. And we basically again want to replicate when we tighten up all the bolts, screws and studs, that on final assembly it's going to be just like this. So essentially the same way how we tightened the case before we started boring the crankshaft bushing. So this is a really important step. All right, so it all comes down to this. And based off what I see and based off what I felt, we have perfect alignment. We have no tight spots, no binding, no issues. So when we get the crankshaft back from AJ, it's going to spin as it should. So this is going to be a good running motor and we have perfect alignment. So that tells us our preparation was spot on. All right, you guys, I appreciate you watching today's video. Just a little secret, don't tell anybody. We're not done with today's video. I still have to get my crankshaft back, I still have to install it, and I still have to set the infloat. But I've had a lot of guys ask me about posting the video, maybe something soon, a sneak peek, which this is. And so we're gonna stop it here. But in about 2 to 3 weeks when I get my crankshaft back, I'm gonna edit this video and I'm gonna add more footage to it. So if you guys are building a motor like this and you wanna see how I do it, stay tuned for that. You can also follow us on Instagram at Classic for Despairs. We do machine work and basically what you watch in this video and other videos on my channel. You can see the same thing on my Instagram. I sell parts for a living, classicfordespairs.com, Triumph, VSA, Norton. So if you guys have any classic bikes, feel free to check out the website. And again, I appreciate you guys watching. Thank you for sharing, commenting, subscribing. I really, really do appreciate that. It helps me out. I really have a passion of showing my machine work because I want to educate people. I want people to know the type of work that goes into making engines work. And I also want to try to motivate and empower people to be able to do things, themselves. So anyways, I hope you got good value out of today's video. And if you guys have any questions, feel free to let me know.